Okay, let's go back to chapter 4 where we solved linear equations in one variable by tables and or by graphing. And what we did when we looked at a table of values is we were looking for when the y values were the same, right? So we came along this table here and we said, oh, where are our y values the same? Well, our y values were here and here the same, which meant that our x values were our solution. And so for this equation here, a linear equation in one variable, we said that x was equal to a -1. And the y values, recall, were what the substitution gave us, right? -1 times 3 is a -3 is a +3, and 3 plus 7, which is equal to 10. And then on the right-hand side, -1 times 5, which is a -5, plus a 15, which in this right side is 10 as well. And we saw that that's what the y values gave us. Well, now we're going to do the same thing for this chapter, except for this chapter, it's both the x's and the y's that concern us. So now if we turn this example number 6 into this new example number 7, which really is not new at all, we'd say, well, here's one equation, y equals -3x plus 7, and here's my second equation, y equals 5x plus 15. What's the solution to the system? So the solution to the system is the same thing as it was before. Where are the y values equal? And then we need that y value and the x value to solve the system. So our system's solution is the -1 and the y value of 10 as well. And that's the solution that solves both equations at the same time. And you'll notice it makes a true statement for here and it makes a true statement for here, which is what makes a solution to a system check out. So again, we would put in here, right, and this would be a +3 and this is plus a 7, and we get that this is 10 over on this side, and 10 equals 10, and so we get it's a check. And here we put -1 in here, so we have a -5, and this is plus a 15. And then we're asking if that's equal to the y value, which is 10, and 10 equals 10, which is a check. So that is showing us exactly what we need it to be. Now, let's go move on to example number 8, and maybe you should go ahead and try this one on your own because you know how fast this is going to solve once I move through the solution. So why don't you pause right now and go ahead and write down the solution on your own. Okay, hopefully you've come back now and you're going to look and see if your solution was correct. So remember, we have a table of values that shows our y values for the first equation, our y values for the second equation using these x values. And now we're looking for where the y's are the same. Y's are the same right here. And so this one is our x value that goes along with that. So the solution to this system is x equals 3 when y is equal to 11. And that's our solution. Now, if we want to see if that's a check again, remember, what we're checking is to see if does that make a true statement in this equation and a true statement in that equation. So 11, is that equal to, and we're asking, right, -2 times 3, and then plus 17. And so we see that -6 plus 17 does give me 11, and 11 equals 11. And so it's a check in that that equation. And then over here, 11 is our y, right? And we're asking, does that equal to 5 times my y, or my x, which is 3, and then minus 4. So 3 times 5 is 15, and 15 minus 4, which is 11. And we see 11 equals 11, and therefore it solves that one as well. So it solves both of these equations simultaneously, which means, yes, that is indeed our solution. And that's solving a system of linear equations in two variables using tables as well, and relating it back to what we had already done in Chapter 4. All right, that concludes section 6.1.